The triangle teeth are pointing the way cold air is moving. Why would there be cold air coming? I apologize if they're so marked up already. This one was good. What's wrong with this one? Over here. Once again, he's got cold air coming from the south. He's got warm air coming from the north. For that matter, if the rotation around this area of low pressure was counterclockwise, why would air be moving on the west side from the south to the north? It would be going like upwind. That doesn't make much sense. Here's a nice occluded cyclone that looks pretty good. He's got a cyclone area, low pressure. He's got an occluded front that meets at a treble point with a warm front and a stationary, a cold front. That doesn't look so bad. This one was the same thing, but I had drawn another L. I've marked over it already now since I did this before. But there's not another low, like the triple point is not another low pressure system or anything like that. This one looks pretty good, not so bad. Here we got an example of one where I got the cold front and the warm front crossing. That's no good. Here's kind of a weird, long occluded front with a triple point and a cold front and a warm front, but he's okay. I mean, he's just got a really long occluded front. This cyclone is dying. He's dead. Okay. So, being able to recognize legitimate pictures of a cyclone is a good idea. But when I said what do cyclones look like, we probably should have been thinking about what do they look like on a satellite picture or something like that. Well, let's draw ourselves a nice looking little cyclone. How about a cyclone? Oops, this is way too big now. Oops. How about an area of low pressure with a cold front and a warm front? Remember, where we actually draw the teeth doesn't matter. This is just notation. And some kind of occluded front up here. Oh, I should be clear about that word, some kind of occluded front. If you actually look through your book with any detail, what you will notice is that your book actually talks about multiple kinds of occluded fronts. There are cold occlusions and cool occlusions, and I can't remember, I think there's 4 types in the book. At least in the previous printing there were 4 types. We are not going to get bogged down with that, okay? We're not going to worry about all the different types of occluded fronts. Keeping occluded fronts straight in and of themselves is tough enough, okay? We're not going to get all bogged down about a cold occlusion versus a cool occlusion and all that crap. Alright, so what would this actually look like on a satellite picture? Well, remember that the leading edge of the cold front is steep. And it has there's just a narrow little area here where the rising motion is happening. But it does tend to be very violent rising motion. It tends to be things like thunderstorms and so on. But it just tends to happen in a narrow band along the cold front itself. On the other hand, remember out here ahead of the warm front, there was all that overrunning happening. As it was a broad area where for hundreds of miles, the whole air mass is just rising slowly over that cold air mass. As this warm air was sliding up on top of the colder air. So we have this big, broad shield of clouds out here ahead of the warm front. And then, of course, we have rising motion near the cyclone itself, because, remember, we talked about the fact that cyclones are areas of low-level convergence. As air comes together at the surface, it's got no place for its air to go except up. So there's clouds around the cyclone itself, too. Now, this pattern of clouds with a band of clouds along the cold front, huge shield of cloudiness ahead of the warm front, and clouds near the cyclone itself, has a name. We call this pattern a comma cloud. But I want to be clear about that. It's the whole pattern that is the comma cloud. It's not just, like you can't look up and say, oh, look, a comma cloud going by. This is covering a huge area. And just for scale, let's put Nebraska on here. Okay, here's Nebraska. Okay? I mean, this is something you would see on a satellite picture or something like that. Unfortunately, on your Blue Line website, there certainly are some pictures of comma clouds. Now, this is almost too good to be true. Most comma clouds don't really look very much like a comma. I don't really know why they picked this word comma cloud. But here's a lovely example of a comma cloud. This is a big area of low pressure. You can practically see its counterclockwise rotation just looking at it, right? It's got an area of low pressure up here someplace, and these are the clouds associated with the area of low pressure. And there's some kind of cold front right here. And you can see there's a relatively narrow band of clouds associated with the cold front. And then there's some kind of warm front out here with a big, broad band, hundreds of miles wide, of clouds out ahead of it. And then this is the occluded front coming in. There are pretty much any day that you look, there are some examples of occluded front, comma clouds on the satellite picture. I have to admit, I have not looked today yet to see if we have one today. Let's actually pull up today's satellite picture. Whether that would probably be a fine place to find such a thing. Satellite images. And of course it's going to make a liar out of me not be one there today. Let's just right infrared. How about for the whole hemisphere? Of course today there would be nothing all that great. This is a common cloud out here. See, there's a cyclone. This is the area of low pressure with the converging winds. Here is a cold front. This isn't a very good satellite picture. And here's the warm front. I can tell because I've got zillions of satellite meteorology courses over the years. This is a cold front. This is a warm front. You got all these warm clouds out here. The big shield of clouds out ahead of the warm front. Got this narrow band of clouds along the cold front. That would be a nice example of a comma cloud that doesn't really look that much like the comma on a keyboard or something like that. Some of these other ones are kind of less effective. It never fails that the day that we actually talk about comma cloud, we kind of use one on the satellite picture. Anyway, let's see if visible also. Yeah, well, you can certainly see. Oh, it actually is kind of prettier on the visible. This is the visible. The other one was the infrared. You see the narrow band of clouds here on the cold front. Here's the cyclone. It's a warm front. Oh, look, and then it connects to another little narrow line of clouds. This is another cold front going into another cyclone. Here's its warm front with its broad cloud shield out ahead of it. This is a nice example of something I wasn't planning on talking about until next time we met. But that's a nice example of what we call a family of cyclones. Cyclones often occur in families, where one cyclone is warm front, eventually becomes kind of a stationary front, farther away from the cyclone where the forces are weaker and the winds are weaker. It becomes a stationary front, and then it becomes a cold front for the next cyclone. And you just sort of have a front with these waves along it, where there are cold fronts and warm fronts. They're all examples of a polar front, right? It all got colder on this side and warm air on this side. So today's satellite picture is actually a nice example of a family of cyclones. So they get these cyclones that are just sort of moving along the polar front. Some places the polar front is shifting to the south, and we call it a cold front. Some places the polar front is shifting to the north, and we call it a warm front. Some places it's not really moving all that much at all because we're pretty far from the cyclones. We call that a stationary front. Today's satellite picture actually is, I don't know that we've ever gotten that lucky to see that good of an example of a family of cyclones one day. So, yep, here's one cyclone. Here's the next cyclone. It probably connects up to here to something else that you can't see very well on that side of the picture. Cool, well that doesn't usually work out that well. Okay. So we've got this idea of cyclones. And we've got this idea that they go through a life cycle. They start, they get stronger and stronger with lower and lower pressure, and then they get stronger and stronger winds, but eventually they become occluded cyclones and get weaker and weaker. This cycle is called cyclogenesis. Now, cyclogenesis is pretty complicated stuff. That's why we've got the PowerPoint about it. You know how much I hate PowerPoint. And that is why we have a video on the website where on YouTube I actually go through and explain every slide of this presentation. There are lots of resources online because I think that this is important, but some of the most difficult stuff that we do. Let's see here if this works. Okay, so here's what we're going to be doing with this business of cyclogenesis. We're trying to explain why cyclones happen. I mean, apparently cyclones are sort of the linchpin to the whole thing, right? Cyclones were why air masses were moving, which is why there were fronts as the air masses moved, which, cyclones are related to this whole business. What we're going to learn is we're going to find out that the polar front causes the mid-latitude jet.